Hey guys, welcome to the next lesson. Today we're going to talk about the correlation coefficient, or what we refer to as R, which is the correlation coefficient. This is something you've probably seen before in your other math classes, but it's a measure of how strong your linear association is. And it's always going to be a number between -1 and 1. And if there's a negative association, then you're going to have a negative R value. If there's a positive association, you'll have a positive R value. And this is kind of what our scatter plot looked like when we looked at our NFL data. We noticed as turnovers increased for these teams, the points scored in general kind of decreased like this. And our scatter plot points did not line up perfectly. If they did, then we would have a perfect negative relationship and R would be -1. As it turns out, the correlation coefficient for our data is -0.5371, which is, it's an okay value for R, but it's a confirmation of what we had said yesterday. We have a moderate or moderately weak association here, right? So this number is confirmation of two things. One, that it's a negative relationship, and two, that it's a moderate to moderately weak one, okay? So we're going to say this about R. R measures the strength and direction of a linear relationship, or we can say a linear association. And that part about linear is critical here. R doesn't measure the strength of curvy relationships, only linear ones. So R measures the strength and direction of a linear association. So if in fact our relationship here between turnovers and points scored is a linear relationship, then this number confirms for us what we had said yesterday. So we'll say that. We'll say if in fact the relationship between turnovers and points scored is linear. By the way, we're going to do a little bit more study into this to see if a linear association really is appropriate. So we'll dive in a little deeper in this chapter. But if in fact the relationship between turnovers and points scored is linear, this correlation coefficient value that we're getting, -0.5371, confirms that we have a moderate negative association. And you could write between turnovers and points scored, but I think we kind of said that already earlier in the sentence. So if in fact the relationship between turnovers and points scored is linear, this R equals -0.5371, this correlation coefficient, confirms that we have a moderate negative association. Now, you don't want to use the wrong word. A lot of times we're tempted to say that we have a moderate negative correlation between turnovers and points scored. You don't want to use the word correlation there. You'll see people do it all the time in newspapers, and when they make reports about data and stuff, they'll say we have a correlation. But correlation is a specifically defined thing. It's what we call R here, right? That's the correlation. So the correlation coefficient is this number, -0.5371. But it's a measure of a linear association. So that's the word you want to use, association. So that number confirms that we have a moderate negative association between turnovers and points scored. So don't misuse the word correlation. It's a specific word tied to this value called R. Okay, if we look at different graphs, different scatter plots, we can kind of estimate what R would be for each of these. Clearly, we have a positive association here, and here they line up perfectly. So this is what a scatter plot might look like if your R was actually 1. And these line up perfectly too, but here's a negative association. So here is a picture of what R equals -1 would look like. Now, of course, in real life, you're never going to see data that lines up perfectly. But if they did, you'd have R equals 1 and R equals -1. Here and here, we have some associations that are pretty strong, right? Not really sure what this R is, but let's say, I don't know, it's definitely positive, right? Because we definitely see a positive association there. So maybe 0.8. This one is even stronger, but of course it has a negative association. So maybe this one would be like -0.9. Now, despite the fact that this is negative, this one is stronger than this, right? So if you're closer to -1, then this one is the positive one, and this is a stronger relationship, right? But they're both pretty good. Now, if I had something like this, where there's basically no association whatsoever, that's when R is going to be close to 0. So R will be close to 0 if you see no association whatsoever. And here, where we see a very strong association, but it's not linear at all, you would also get a value of R about 0 here too. And that's what we mean when we say it only measures a linear association. It doesn't measure the strength of a curvy association. So this is a very strong association here, but the correlation coefficient R only measures linear associations, not curvy ones. All right, so coming up next, we'll have a few more facts about this thing called the correlation coefficient coming your way next. Okay, let's talk about a few facts about correlation, this thing called R. First of all, we mentioned it, but it is a number that's always between -1 and 1. If there's no relationship whatsoever, no linear relationship whatsoever, it's going to be 0. If it's a strong positive one, it's going to be close to 1. If it's a strong negative one, if it's a strong negative association, that is, it'll be close to -1. Another fact about R is that it's unitless. It has no units. So in our football example, that number, -0.5, whatever it was, there's no units attached to it. So R is a unitless number. We mentioned this, but we should write it down. R only describes linear relationships. So that's important. Other facts about R. Let's see. Oh, this is a good one. R only describes an association between quantitative variables. Let's see. Only describes an association. That's better, I think. R only describes an association between quantitative variables, not categorical ones. So we're not going to use R if we are describing the association between gender and study habits, right? Can't do that with categorical variables. You can only do it with quantitative variables. Other facts about R. Let's see what else we got here. Another good one. R is not resistant to outliers. So it's not resistant. So outliers will affect your R value. In fact, in our NFL data, we identified 2 outliers. Remember this with the Buffalo Bills up here and New York Jets down here. And you can literally see it. If we remove these 2 teams from the data set, you see a stronger relationship, right? So in that case, we'd have a different R correlation coefficient. In fact, I calculated it. I eliminated the Buffalo Bills and the Jets from the data. And the new R, instead of being negative 0.537, it was a lot closer to negative 0.6, which makes it stronger, right? Closer to -1. So outliers definitely affect your R value, your correlation coefficient. So yes, R is not resistant to outliers. And R does not change if you change the units. Of your variables. And that should make sense, I think. So R does not change if you change the units of your variables. So for example, if we measured, let's say, somebody's span of their hand, like how wide it is, and then measured their height, you would imagine there would be an association between those two things, right? Taller people might have wider hands than shorter people would. So we'd probably see a pretty strong association between those things. And if we measured this in inches and we measured height in inches, we could do that. But we could also change it and measure this in centimeters and height in inches. But the association is going to be the same, right? So if I change the units for either one or both, the relationship or the association is going to be as strong as it is. So that should make sense. So if you change the units on your variables, it won't affect R whatsoever.